I have told you earlier that three factors can change the chemical equilibrium position for a reversible chemical reaction. The three factors are number 1, temperature, number 2, pressure, and number 3, concentration. All the three factors can change the chemical equilibrium position, but among them, only temperature has its effects on chemical equilibrium constant. In this video, I am going to show you the effects of pressure on chemical equilibrium position. I repeat, chemical equilibrium position for a reversible chemical reaction. In chemistry, for a reversible chemical reaction, three things can happen. The three things are number 1, when the number of mole of products is greater than the number of mole of reactants. Number 2, when the number of mole of products is less than the number of mole of reactants, and number 3, when they are equal. So case 1, when the number of mole of products is greater than the number of mole of reactants. Let's consider an example. In a system, phosphorus pentachloride reacts to produce phosphorus trichloride and chlorine gas. We can see that one molecule of phosphorus pentachloride is producing one molecule of phosphorus trichloride and one molecule of chlorine. That means 1 mole of phosphorus pentachloride reacts to produce 1 mole of phosphorus trichloride and 1 mole of chlorine gas. That means the number of mole of products is greater than the number of mole of reactants. So in this system, one molecule of PCl5 is producing 2 molecule of products. They are PCl3 and Cl2. That means the number of molecule in the system has been increased, and so the amount of pressure will be increased automatically. Now come to the Le Chatelier principle. Le Chatelier principle states that what system automatically does, we should do the opposite thing so that the chemical equilibrium position bound to move to right to produce more products. So in this system, as the amount of pressure has been increased automatically, we should do the opposite. That means we should decrease the pressure to move the chemical equilibrium position to the right. So for this chemical reaction where the number of mole of products is greater than the number of mole of reactants, we should decrease the amount of pressure. So if we increase the amount of pressure, the chemical equilibrium position will bound to move to left. So if we increase the pressure over here, the chemical equilibrium position will bound to move to left side of the chemical reaction, causing the amount of PCl5 increase. Now come to case 2, where the number of mole of products is less than the number of mole of reactants. Let's consider another example, where 1 mole of nitrogen reacts with 3 mole of hydrogen to produce 2 mole of ammonia. That means 1 plus 3 is equal to 4 mole of reactants reacts to produce only 2 mole of products. That means in this system, we have 4 mole of reactants. They produce only 2 mole of products. That means the number of molecule in this system has been decreased. So the amount of pressure will also be decreased. Now come to the Le Chatelier principle. We know that according to Le Chatelier principle, what system automatically does, we should do the opposite. In this system, the amount of pressure has been decreased automatically, so we should increase the amount of pressure to move the chemical equilibrium position to the right. That means if we increase the pressure for this chemical reaction, the chemical equilibrium position will bound to move to right, and the amount of ammonia will be increased and the amount of N2 and 3H2 will be decreased. So in summary, we can say that the chemical equilibrium position are bound to move to the side where the number of mole is lesser. Now come to the case 3. Case 3 means when the number of mole of products is equal to the number of mole of reactants. Let's consider an example. 1 mole of H2 reacts with 1 mole of I2 to produce 2 mole of HI. That means 2 mole of reactants producing 2 mole of products. That means the number of molecule are remaining same. So the amount of pressure will also be same. So we can say that according to Le Chatelier principle, the the position of the chemical equilibrium will remain same or remain unchanged for the chemical reaction where the number of mole of products is equal to the number of mole of reactants. So these are the explanation for the effects of pressure on chemical equilibrium position for a reversible chemical reaction